Hello! Let's talk parent functions. These are super important, my friends. So you are going to want to have these memorized. You probably already have a bunch of them in your head already. Let's make sure we've just gone through all of them. So we're going to go from simplest to more complicated in these parent functions. First one we got is the constant function. That little c right there can be any number. And the function always looks like a straight line at that number. So if I have f of x equals -1, it's going to be a straight line through -1. F of x equals 4, straight line through 4. As always a straight line through that number in the y-axis. That's the constant function. Next we have our identity function, which is our basic linear function. That's usually what I'll refer to it as. It's the most basic linear function out there. F of x equals x, or y equals x. Gives you that diagonal line. Next, we have our absolute value v. You'll notice that it is the linear function that we just did, but reflected up. Because anytime you put negative numbers below the x-axis into the absolute value function, it makes them positive. So it gets flipped up to become a positive. So there's our absolute value v. Next one is the quadratic function. I have nicknamed this one the smiley face function because that's what it looks like. The smiley face quadratic function we will come back to later in this semester. We're going to be talking about it a lot more. There you go. There's my smiley face. That's a really bad smiley face. Ignore that. It's okay. But you've dealt with the quadratic function before. It's our basic U shape. It could be flipped up, flipped down. We're going to be dealing with that a lot later. And then we also have that compared to the cubic function, which is sometimes called the odd function, even, odd, based on the exponent. And I usually call this the dead worm function, because that's what it looks like to me. A dead worm on a sidewalk after a rainstorm. So this is my dead worm right there. That's our cubic function. Once again, we'll come back and deal with this one a lot more later. Next, we have the reciprocal function. This is also called the basic rational function. We will have an entire chapter on rational functions that we will deal with later. But notice for now, this one does have an asymptote right here in the middle. If you don't remember asymptotes, they're those invisible lines that our graph gets closer and closer to but never touches. So this one actually has two asymptotes, one vertical, one horizontal. We have the reciprocal squared function. Now remember, squaring negative numbers makes them positive, so you notice this looks like the reciprocal function just flipped up because it's making the negative part positive by squaring it. So there's that one. Next we have our square root function. This one is very interesting. We're going to talk about this one more in a little bit because notice that this end of the function comes to a point. All these other functions have arrows on the ends. This one does not. It comes to a point. That is why you'll notice over here the brackets are included. We're including 0 because that point includes the origin. So that is something that's very, very unique about the square root function. The cube root function does not end at a point, keeps going forever and ever both directions. Once again, that's because we can cube root negative numbers. We just cannot square root negative numbers, so that's why it ends. So those are your basic parent functions. Please work on memorizing those. They are very, very important. We're going to use them all semester long. Okay, next, okay, we're doing good. Let's talk about x-intercepts real quick. Now, something about x-intercepts, you will hear all three of these words used in this class. They all basically mean x-intercepts. There's a couple exceptions. We'll talk about those later. For now, just know these are all meaning the same thing, and they all mean set it equal to 0 and solve. That is what they mean. If you see any of those words, x-intercept, 0, root, it means set the equation equal to 0 and solve it. That's what it means. Let's see. So we will deal with that a little bit more later. We'll come back to this idea of x-intercept and zeros and roots multiple times. So let's move on to graphing piecewise functions. We dealt with a piecewise function at the start of 1.2. Now let's graph one. Now this can sometimes be really difficult for students. So I really want to go slow with this so you can see what's happening. So what I would like you to do is a piecewise function, literally think of it in pieces. Don't try to think of it as a whole and do it all at the same time. So this first one, I'm going to look at this piece. X is less than 1. It's also equal to, we'll get to that in a second. So I am going to do this. X is less than 1. And I want to box all of that. Now, technically, this does keep going forever and ever because I just want right here at 1 and then keep going forever and ever. X is less than 1. Now, the next piece is from 1 to 2. So then I'm going to come in here, highlight the box from x equals 1 to x equals 2. So I got from 1 to 2. That's my second piece. The third piece is greater than 2. So I got my x equals 2, and I'm just going to box all the way to the right because I just want it greater than 2, all of that space. So these are my three pieces. So now let's go through and graph them. My first piece is x squared. Notice that's one of your parent functions. So let's just graph it right here. My quadratic parent function starts at the origin and then makes my parabola shape. If you're not sure how I'm getting these numbers, this is x equals 1, so 1 squared is up 1. This is x equals 2. Woo! What's it doing? There we go. This right here is at x equals 2, so 2 squared is 4, so I went up 4. That's how I'm getting those points. Now, I've got this parabola shape, but I only want this shape in my first red box. I do not want it anywhere else. So anywhere that is outside of my red box, I can go back and erase it. Oh, whoa. There. Okay, sorry. Computer issues. You know how that is. There we go. So this point over here was outside of my red box. I don't want it. These points are all inside my red box. I want them. Now, look at the point on the line, this point right here. That point should be a closed circle if it is included, meaning less than equal to, greater than equal to. It should be an open circle if it's not included, so just less than or greater than. So I want to look at x equals 1 on my thing over here, and I have equal to, which means closed circle. So I drew that correctly over here. I have my closed circle. That first piece of the piecewise is done. So let's do the second piece. I got 3. Okay, that's my constant function. I know that is a straight line at 3. So 1, 2, 3. Straight line at 3. Like that. Now, once again, I only want it in my orange section from 1 to 2. So I'm going to erase everything else so that it is only in the orange section. Now for my circles, look on this end, it looks on the left end, I've got an open circle, and on the right end, I have a closed circle, because no equal to, and there is an equal to. So I come back over here, open circle over there, closed circle over there. Ta-da! Okay, last section, I have X. I know that one. That is my, whoa, let me do this right. Hello. Diagonal line. My basic linear function. Now, once again, I only want this drawn in the yellow section. That's it. That's all I want it to be drawn in. So, I am going to erase the other sections so that it is only in my yellow section. And what circle do we need? Come back over here. That is an open circle because there's no equal to. So open circle. And there you go. There's your first piecewise function. In the next video, we're going to talk about even and odd functions, and that should just about wrap us up for 1.2.